So we say there are different architectural styles. So different styles can be used to meet different needs, and they break up the system in different ways, different components, or their components would be connected in different ways. And these are the, the main, some of the more common architectural styles. There are definitely more. And also, sometimes you can combine two architectural styles or you can modify it. So it's really up to you to change the architecture, the basic architectural styles to meet specific needs. But for one thing, why, can I ask you, why do we want to break up our systems into several components? Okay, well, if we break up a system into several components and we can give some responsibility to each component, that means two things. Each component will be simpler than the original system. So each component itself will be easier to build. That's one benefit. The other benefit is for perhaps coordination, because now you can assign one team to one component, so the work allocation, work assignment to people can be more effective, and you can have different teams, each team work on one component at a time. So it's much better than one big system, monolithic, or a very simple system that is just huge. Is going to be very difficult to manage the work. So dividing them up into components have the benefits of management of the project team. Okay, and of course the resulting software will also be more manageable. Okay, we can see some actual example. For example, MVC stands for Model View Controller. Okay, so it divides a system into the view which is visible by the user, and then the user would give their input to the controller. The controller would manipulate the model or the data, and then the display will be refreshed. So you can follow the arrows, the direction of the arrows, to see how the users interact with these three main components. So why I said it's easier for software development? Well, now you can assign one team to do the view, one team to do the controller, and one team to deal with the data. Okay, they all can work in parallel nicely. And assuming that you have defined the interface carefully and correctly, then when they put together, integrate together, so hopefully we don't have to go through too much trouble to make them work. Although integration is still a big task. And how about software maintenance? In maintenance time, if I tell you that I want to update how the display is shown to the user, okay, then if the system is built by MVC, then you know you only need to go to the view component. So now instead of finding from a big system where to make the change, you only need to, you limit your size to 1/3, let's say. So 1/3. So as a software maintenance programmer, your job is easier because now things are divided into three parts. And you know, if you want to change the business process, then you would go to update the controller. Okay, if the data has changed, then you would go to change the model, although that should not happen too often, okay, unless you have new business. Otherwise, the data should not change. So that is the MVC style. Another style is called repository style. In a repository style, repository is just a fancy word for data storage. So the subsystems would call the same repository to create data, to update data, to read data, and then to query data. And so again, it has the benefit that if it's data related, then you only need to know that you're going to look at the repository. If it's about using the data, then it will be one of the subsystems right here. So at least it is easier to deal with than one big system. Okay, and also, of course, this you can assign this to one type of hardware, and the subsystem can be assigned to one type of hardware. And drawbacks are that the repository can be a bottleneck. Of course, you can have uh, some technology to help you spread out the work here. Okay, to reduce the bottleneck. And also another drawback is, well, the systems looks like it's just divided into two parts. So it's not a huge difference than just having one huge big system. Okay. Another, if you compare these two diagrams, the pattern looks almost the same. Okay, so these are just called client, and the right hand side is the server. It's just changed the name from repository and subsystem. So are they the same or are they different? Well, it's I guess the connection, the structure is the same, but the task you assign to them is slightly different, because the server side, you can really do, if you want, you can really do more than just data storage. You can do some business processing here too. So I would say it has a benefit over the repository style, is that you have a little bit more flexibility of decide of putting more work here. So, and but of course that's also is a strength, but it's also uh, a weakness or maybe a source of confusion, because when you're designing, now you have to decide where to put some logic. Okay, and at some point in your career, there's a typo here. I should say thick client or thin client. Thick client means the client would do lots of processing. Okay, so very little is done by the server. Thin client is just the opposite. The client would do very little, and the server will need to do more. So in fact, in the past few decades, the computing trend switched from thick to thin and thin to thick, back and forth, maybe 2 or 3 times. Okay, so it really somehow depends on the technology at that time. Sometimes the technology or the usage of the computing services favor thick or favor thin client, but that is one decision designer need to make. Okay, and so that is the client server style. Another style is peer-to-peer, okay, or P2P. Uh, there are two main kinds of peer-to-peer system: hybrid peer-to-peer and pure peer-to-peer. And in case of hybrid, some peer would have extra responsibilities. Okay, so there's, but these other ones, pure P2P, then no one is super. So everyone is the same. Okay? And is this a very important architectural style? In a way, it is. For example, BT is a very well-known P2P content sharing. Actually, I'm not. I prepared these slides maybe several years ago, so I'm not sure if it's still the same. But imagine in 2013, 6% of the total internet bandwidth is used for file sharing. So that means I produce something for other people to use. I share a file. Okay, sometimes it's legal, sometimes it's not legal, and half of that 6% happened on BT. I remember actually when I was doing my PhD maybe 12 years ago, 10, 12 years ago in England, uh, in the residence, they forbid all students to use BT. Okay, they disallow people to, because otherwise the whole the bandwidth will be gone. So this Napster is one example of peer-to-peer. What it shows here is that user 1 and user 2, they are willing to share some of their files. It may be music, maybe software, or anything, or the photo they take, and they tell a hybrid server, okay, a Napster server. And then if user 1 uh, need a piece of music, right, and it asks Napster, and Napster find out that, well, user 2 has it. So the server return and tell user 1 that the music you need, user 2 has it. So the software, I can use the software to ask user 2 to give it to me, and then it will stream to, it would be sent to me, like maybe usually uh, go through some slow speed, like relatively a slow backend process. So you can see the server only deal with matching them to tell them. So the server is not involved in actually the file sharing. So this is, I guess, how Napster can get into that gray area, whether it is legal or not legal. Okay, so sometimes I think they have some lawsuit. Actually, even before Napster, there may be different time. Sometimes they get into legal problem, and then but usually they can survive for at least several years. So the server's workload is not too bad. It's not involved in all the actual file sharing. It's only in sharing the file name and also the user ID. Okay. So another style is 3-tier: presentation tier, business tier, and data tier. If I ask you, is this style the same as MVC? Do you think they are the same, or do you think they are different? Okay. I think I asked this also before in an exam, and they're different because the user only deal with the presentation tier. So each tier work with the tier below it. Okay, so each tier is used by the tier. 可唔可以細聲啲啊？OK，即係我諗我俾你傾偈都已經即係俾晒面你哋啦，咁你都俾少少面我得唔得？OK，細聲啲好唔好？至少唔好我俾我聽到，好嘛？Thank you。 So presentation tier, talk to the tier, very funny. Yes, very funny. So presentation tier, talk to the tier below, business tier, and then the business, they, so business tier receive a request from the presentation tier, and since it couldn't finish its task, it requires the support from data tier. So each tier provides support to the tier above, and is the user only deal with the top tiers. Okay, so unlike in the MVC, is the user sort of deal with two components, the view and the controller. Okay, and it sort of go like a circular, uh, the flow goes circular, but this one is going from top to bottom and then bounce back up. So this is not, this is like in one line, down and then up, down and then up. So this is not a circle. And but each tier work on one type of things, and we can both MVC and 3-tier are very, very popular, and we can generalize 3-tier to N-tier. And some of you have learned about the OSI 7-tier reference model for communication. Okay, and it has 7-tier. Each tier does something specialized. But the problem with having many tiers is efficiency, because if you have to make so many level of call, and then each level return up, is actually it slows things down quite a bit. Although some more relaxed approach allows you to call kind of skipping, for example, this to call directly here, but uh, depending on the design, okay? But still 7 tiers, uh, when you need to find out, oh, I have a task to do, where should they go to? Do they belong to this tier, that tier, that tier? So sometimes if you have too many tiers, it's quite hard for you to decide which tier I should assign to. So the internet use a very practical approach. So it's did not go to the 7 tiers, but have 4 tiers instead, and which maps quite nicely link to the Ethernet or the Bluetooth or Wi-Fi, and then there's the IP level, and then above it there's a TCP and UDP, and above it is still the more application like FTP, Telnet, Messenger, and so on. So so we can have 4 tiers, 5 tiers if necessary. And lastly, it is the pipe and filter style. Pipe and filter style will have multiple filters here. In this example, we have 3 filters and 2 pipes connecting each adjacent pair of filter, and there's an input and output. So input goes from here, output goes here. For example, think of this. This is a compiler, the structure of a compiler that has 5 filters. Okay, so instead of 3, you can have 5, you can have 6, you can have 4. So each filter does something special. For example, on the left-hand side is the lexical analyzer. It takes a Java source code or C source code, and you know that in a C program, you have all the things are characters. Okay, so you have one character, one character, one character, and it's very hard to make sense out of these characters. So the lexical analyzer would group related characters into tokens. For example, if it sees a bunch of alphabetic letters and on the left hand side there's a space, right hand side there's a space. So the lexical analyzer would recognize that these several alphabetic characters would be a variable name or would be a keyword. So the lexical analyzer would group them together and make it into a token. Okay, so if you have maybe your source file may have several thousand characters, but if you group several related characters together as one token, that several thousands characters will become maybe several hundred or 1,000, 1,000, 2,000 tokens, which is much more easier to manage. So after producing the list of tokens, it sends to the next guy. Okay, the next guy. The next guy is a parser. A parser would, I think I took out that other diagram. But let's say I show you parse tree. Let's say arithmetic expression. Let's see if I can. Well, for example, this is what the parser does. So the parser is given some numbers. Of course, a number may not be a single decimal digit, maybe 721 plus 33, let's say. So 721 plus 33 would be sort of built into a tree like this. And that is the task of the parser. Okay, we'll take the tokens and turn them into program structure, sort of like a tree structure. So that is one thing, like it's one task. Now it gives the program structure to the next person, the filter tree, semantic analyzer. So semantic analyzer would do some analysis. For example, it would see that, oh, maybe you're trying to add two variables together using a plus sign. So it will check whether is it an integer, is it the same type, or if it's not the same type, one is floating point, one is integer, then the semantic analyzer would have to do some conversion for you to convert the integer to floating point. But maybe you're trying to add an integer to a string, then maybe it will tell you it's error. Okay, so that is the job of semantic analyzer to analyze whether the tree that produced by the parser is a correct program. And after that, it will also send its output. The output would be in the form of some intermediate code, some code recognized by the compiler. And the fourth component is called an optimizer. Many of you have not used, I think, how many of you have used C before? C programming 係咪好多都有啊 ？OK， 有邊個冇學過 C 㗎呢度 ？OK， 都有一個 OK， 其他嗰啲人係全部都識 C 㗎嘛係嘛 ？OK， 咁C 你哋譬如有冇學過喺個 compiler 嗰度咧係用 optimize for space 啊或者 optimize for speed 呢啲嘅 compiler option 㗎？有冇試過用過？未聽過係咪？其實有呢啲咁樣嘅 option 嘅喎。咁呢啲咁嘅 option咧，其實就係呢一個 optimizer 做嘅嘢。不過即係可能你因為你用嘅咧唔係啲production 嘅所謂 production 嘅 software，因為先生就係要你compile run 咗就得啦。譬如 optimizer 咧係可以咧係你俾個即係當然俾個你要俾個 option 啦，即係你要 select 話我想 optimize for speed 嘅。亦都可以 optimize，即係一個可能性就係 for 個 speed 啦，即係啲 code 係要 run 得快啲。另外一個咧就係 optimize 要啲 code 係細啲嘅，因為細啲嘅時候就可能冇 run 得咁快。OK，咁呢個咧就係 optimizer 做嘅嘢，佢就將嗰啲 intermediate 嘅 code 咧會 translate 咗，雖然都係 intermediate 嘅 code 嚇，但係即係呢度出 intermediate 嘅 code，呢度亦都再出即係 revise 過啲 intermediate 嘅 code，然之後咧到收尾嗰個code generator 嘅時候咧，佢就真係咧就出一啲嘅 executable 嘅 code 啦，即係順便亦都可以講埋，即係因為咧，如果我講多啲嘅 compiler 咧，就可以俾大家咧可以明白多啲 architecture， 即係一個你選擇一個適當嘅 architecture 嗰個重要性。OK 嗱。譬如果我而家係寫緊一個 C compiler 嘅嗱，大家知道 C language 同埋 Java language 咧，其中一個分別咧就係咧 C language 咧佢 compile 咗嗰啲 executable 咧就係真係行 machine code 嘅。OK， 所以點解 C 啊 C 加加咧呢啲係傳統上面咧，即係我哋係話比較快嘅 language。但係點解 Java 咧係稍為係冇咁快咧？因為 Java 咧佢哋出咧係出byte code，而 byte code 咧係 run on top of virtual machine 嘅。咁你既然即係話咧，佢唔係話直接 run 喺嗰個電腦，即係譬如你用緊 Intel processor，咁佢就用個 Intel 嘅嗰啲 instruction set。佢其實佢係 run 緊 virtual machine，咁嗰個 virtual machine 就 support 一啲 byte code 嘅 instruction。咁然之後個 virtual machine 先至係 run。咁呢個亦都係其中一個原因咧，點解 Java 係一個即係被稱為係好 portable 嘅 language？ 所以初初出 Java 嘅時候咧，佢哋係俾人 position 做咧就係一個 internet 嘅 language， 就係咧即係話可以喺 server 嗰度咧掟翻啲 Java code 學去你嗰部手機又好，即係當然初 Java 出嘅時候未有 smartphone 啦。咁你無論你個 hardware 係 Intel 啊，抑或唔係 Intel， 你有個 CPU， 你只要有嗰個 virtual machine， 有個 JVM， 你就可以 run 到我啲 code 啦。OK， 咁所以咧，即係佢係用同一 set 嘅 byte code 就可以喺唔同嘅 hardware 上面 run。咁但係咧 C 就唔得啦，即係 C 佢嘅速度咧，佢係因為佢 gen 啲 code 出嚟咧係 gen for 我係要呢一套 instruction set 嘅，咁先至係可以。OK。咁而家講翻嗱，講咗一啲咁嘅 background 啦，咁我哋就可以睇翻，如果放喺呢個 architecture 嗰度咧，可以俾 C 有啲咩嘅好處或者唔好處咧？譬如舉一個例，而家有某間公司出咗個新嘅 CPU， 佢嘅 instruction set 係完全唔同嘅。咁如果作為我係一個 C compiler 嘅公司咧，我出 C compiler 咧，咁樣咧。呢度咁多個 component， 其實我只需要換一個，我就可以 support 到呢個新嘅 hardware， 即係有新嘅 instruction set。大家估唔估到會係邊個咧？ Okay， 就係最收尾呢一個嗱，因為 C language 咧本身其實個 C language 就係 C language 嚟㗎嘛，咁所以其實前期呢一啲嘢咧係冇分別㗎嘛。咁所以呢個我哋就叫 front end， 呢個後邊呢啲咧就叫 back end。咁如果你將個 C 咧轉咗去第二度嘅時候咧，即係去第二個 hardware， 當然有一個唔好處咧，就係個 programmer 咧要 compile 多一次，我 compile 落去呢，即係要compile多一次係 for 呢一個嘅。咁但係咧 個 compiler 嗰個 software 嗰個公司咧，就只需要換咗呢一個 code generator 嗰部分，咁就已經可以即係就行到啦。咁所以你可以睇到咧，即係有一個hub。如果嗱，譬如假設我哋唔係用呢一個咁樣嘅 architecture，如果用 let's say 用之前嗰啲嘅 architecture 咧，可能會好難搞。OK，即係變咗我哋咁變咗，如果我用一個啱嘅 architecture 嘅時候咧，就可以即係減輕我個 code 即係要 update 嘅嘢，我就可以轉過。咁甚至乎咧，以前咧我亦都譬如亦都係可以咧，就係假設我間公司又要寫 C， 又要寫 Fortran 咁先算啦。OK， 因為 Fortran 都係 compile 嘅 language 啦。咁如果我又要寫 C 又要寫 Fortran 嘅時候咧，咁我會搞啲乜嘢咧？即係其實呢5個 component 咧，我就變咗淨係需要換前期就得咯喎。即係因為 Fortran 同埋 C 佢前期呢 lexical analyzer、parser、semantic analyzer 呢3嚿嘢咧係應該係唔同嘅。咁所以咧，即係如果我本身我有一個 Fortran compiler，而家想 develop 個 C 嘅 compiler 咧，我就只需要再做呢3嚿就得啦。另外呢2嚿咧就可以即係唔需要喎。咁所以呢一個嘅 pipe and filter 咧，即係喺某啲情況底下咧係可以唔使我哋由頭寫過個 compiler 咯。OK， 咁但係當然可能有好處有唔好處嘅，因為如果你係有咁樣嘅 component 喺度咧，會唔會呢一個 compiler 一定係行得最快咧？可能唔會嘅，即係可能因為由於佢要 stick with 某啲嘅 interface 咧，即係佢呢個 compiler 一個咁樣可以 plug and play， 即係唔係應該話係 plug 唔同嘅 component 又 support 唔同嘅 language，plug 唔同嘅 component 又 support 唔同嘅execution hardware 咧，係可能會係影響到即係佢個整體嘅速度。即係如果我要寫一個咧係專係 for 呢一個programming language， 專係 for 呢個 hardware， 我有機會係將呢啲傳到係好緊，即係 performance 係好好嘅。咁但係呢個就要係一個嘅即係設計上面嘅取捨，究竟我點樣係？所以呢幾個嘅style 咧有喺度俾大家選擇咧，就係其實我哋未必話係有所謂係邊一個冇一個所謂最 universal 最好嘅 architectural style， 而係視乎邊一個嘅情況底下，邊一個嘅 architectural style 咧係比較適合。OK， 咁所以呢個係一啲嘅取捨，呢啲嘅係考慮。OK， 咁我哋take個5分鐘嘅 break 就去下一 part。